All right, so let's talk about blood grouping. I'm sure everybody has heard, oh, I have type A blood, or I have type A positive blood, or I have type O negative blood. We're going to talk about what that actually means. So, two terms you should know: transfusion and infusion. Trans means across, okay? So transfusion means that you are transferring blood or blood components from one individual to another. That could be plasma, that could be packed cells, that could be platelets, that could be whole blood. But either way, you're actually transferring blood itself or a component of it. Infusion is a bit different because it has nothing to do with blood as much as just fluid volume. Now, admitted, it's going to be either saline or glucose or something like that, but all they're trying to do is increase the volume of your blood. This will happen in cases where somebody goes into shock. A real good example of this, when I was in college, I broke my ankle. And I kind of went into shock when it happened, and my blood pressure dropped, and I was very, very cold. And the first thing that they did was they put saline. They put a saline drip into my hand, basically just trying to get my blood pressure to go up. It wasn't that I was bleeding anywhere. It wasn't anything like that. It was just that attempt to give me more volume so my blood pressure would rise. Antigens versus antibodies. Okay, an antigen is a surface protein. We discussed this way back in AP1 in chapter 3. We talked about marker molecules as a way to identify the cell as belonging in your body. And that's exactly what this is. It's an antigen that is a surface protein that basically says, yeah, that's normal. Now, an antibody is something that can bind to a surface antigen, okay? Now, our antibodies kind of look like a Y, okay, with a crab claw at the end. Now, mind you, this crab claw can move. Think about dancing YMCA and your hands are up in the Y shape, right? But that doesn't mean you're stuck in that shape forever. You can move your arms down or forward or up or whatever. This actually works kind of the same way. While the crab claws are the piece that binds to the antigen, the arms of the Y can actually move so that they can grab onto different things. Now, antibodies. Antibodies are specific to a certain antigen. So if I have an anti-A antibody, the only thing it binds to is A. It won't bind to B, it won't bind to anything else, just A. So when an antibody binds to an antigen on red blood cells, they form these molecular bridges, basically attaching multiple red blood cells together. They form a clump, and that clump is called agglutination, which I'm going to show you in just a minute. Now, the complex of all of these cells being clumped together can cause something called hemolysis, okay? So let's look at what I'm talking about as far as what's on your cell. So this is a red blood cell. These would be the antigens that are on the surface, okay? Now, notice that the antigens look different. So you've got one that kind of looks like I don't know, circular structure, like there's a scooped out circle here, where the other one looks like a triangle would fit. Each one of these antigens has a specific shape. That's why they're different from each other. And the antibodies are going to specifically bind to the one that they fit into. So this shape right here would actually fit into this shape right here, but it wouldn't fit into that shape right there, okay? In the human, there have been 35 blood groups that have been identified, but there are two primary groups of antigens that are displayed on red blood cells. So, going back down to agglutination. So remember what I said about the Y being able to bind to different things. Each one of these arms with its crab claws can bind to one of these antigens, okay, that are on the surface of the cell. So I can bind to multiple cells. Remember that my arms move. Now, when this happens, when I'm binding to multiple cells and then those cells get bound to by another cell or another antibody, this clumping that you are seeing here is called agglutination. Okay, it's basically a whole chunk of these things being held onto by antibodies. Now, the hemolysis that I talked about, hemo, blood, lysis, to break. So go with me on my journey. I've got a person who is glued to the sides of a car. Let's say their hand and their foot is glued to, the right hand and their right foot is glued to one car, and their left hand and their left foot is glued to another car. I know, just go with me on it. Now, let's say those cars are going at 75 miles an hour down the highway. What are the chances that that person is going to survive that without getting ripped to shreds? Probably not all that great, because 75 miles an hour and keeping the cars the exact same distance away from each other and not squishing them and all of that, not ripping them apart, etc., that is pretty low chances, right? Well, you've got to remember that if this is in the bloodstream, it is being pumped really quickly through these vessels. And if you've got this huge clump being held together and these antibodies don't let go, this is like super glue. Eventually, what can happen is the shearing forces can actually rip the cells that are being held together like this one, or this one, or this one. It can be ripped apart. If this were one car and this were another car going 75 miles an hour, that was terrible. If this were one car and this were another car, and they were going 75 miles an hour down the highway and one of them slowed down or one of them sped up, this poor cell is going to get ripped apart. That's hemolysis. Okay? So when I talk about hemolysis, that's what I'm talking about. Now, we have two blood groups. We've got the ABO blood group and we've got the RH factor. Now, the reason that I make the distinction is because the coding for the ABO is on chromosome 9 and the coding for the RH factor is on chromosome 1. So, whoops. So let's see. Again, go with me on my journey. It's not going to make sense at first, but I promise it will at the end. So, shirts and pants. If I'm wearing a shirt, does it automatically mean I have to be wearing pants? No. If I'm wearing pants, does it automatically mean that I'm going to be wearing a shirt? No. So, kind of like it's on the same body, but it's two completely different things. That's how the ABO blood group and the RH factor work, okay? Both of them are expressed on the surface of the red blood cell, but their controls are completely different. So again, let's go back to the shirts. Let's say that I can wear a long sleeve shirt. Okay, so I've got long sleeve. Or I can wear, I can wear a short sleeve shirt. So I've got long sleeve, I've got short sleeve. Now, another option. I can wear both. I can wear the long sleeve with the short sleeve on top. You know, when it's cold, but it's not so cold that you need a whole entire sweatshirt. So I can wear long plus short. Or I can be really, really cray-cray, and I can wear no shirt at all. Okay, so let's say these are my options when it comes to A, B, and O. Okay, so I've got A showing, I've got B showing, both A, B, and then when I don't have any shirt at all, that's called O. So drawing this out, here's my red blood cell, type A. Type A would show the A antigen on the cell, but only the A antigen. Type B would show the B antigen on the cell, but only B. Okay? Type AB, well, in that case, you're going to show both A antigens and B antigens. And then with type O, there's nothing. See how there's nothing showing on the surface of this cell? So this would be type A. This would be type B. This would be type AB. And this would be type O. I always think of O as 0 because it means neither one is showing. Okay? Now, let's switch to Rh factor. Rh factor with our person is going to be, it's either there or it's not. So again, I'm going to go with they're either wearing pants or they're not. So pants or no pants. Now for Rh factor, it is either there or it's not there. So you can be Rh positive, it's there, or you can be Rh negative. It is not there. Okay? So again, if we're looking at this as if it were cells, you either have Rh in which case you are positive, or you don't have Rh, in which case you are negative. Okay? All right. Well, actually, I'm going to scoot this up, I think, if I can grab it. So, here's a blood cell. A. If this is all you see, you just see the A antigen and nothing else, this is going to be blood type A negative. Because I only have A, you don't see Rh. If I have a blood cell that has the A and the Rh, then I am A positive. Because this and this are only referring to the Rh factor. This is the ABO blood group, okay? And remember, shirts versus pants, they're not necessarily going to influence each other. It's just, is it there or is it not? So that's A positive. Sorry, this is taking 50,000 years. Okay. Red blood cell. B antigen on its surface. Or B antigen on its surface with Rh also there, present. So this would be B negative because it's got B, but it doesn't have Rh. This, however, would be B positive because not only does it have B, but it has the Rh factor as well. AB. With Rh on the bottom. So this would be AB negative. This would be AB positive. Negative because there's no Rh factor, but there is A and B on the surface, so it's AB. Same here, A and B on the surface make it AB, but now we've got the Rh factor, so it's positive. Now, this would be O because there's nothing on the surface as far as A or B. And do you see Rh? No. So that would be negative. Whereas this, there is no A or B, so that would be O. But it does have Rh, so it would be positive. Okay? These are the most common blood types that we have. These 8. A positive, A negative, B positive, B negative, AB positive, AB negative, O positive. These are going to be our most common blood types. Now, here we go. Here's type A, here's type B, here's AB, here's O. Again, remember, this is chromosome 9. I'm either short sleeve shirt, long sleeve short, short and long sleeve shirt, or no shirt at all. When you can see both, like what's here, we call that codominance because you can see both. They are both technically dominant. So they're dominant together. Now, with the Rh factor, like I said, you either see it, so you're positive, or it's not there, and then you're negative. So we've got A negative. There's A positive. We've got B negative. There's B positive with the Rh factor. Rh factor. AB negative, AB positive, O negative, O positive. Now, let's talk antibodies. If somebody is type A, okay, so somebody looks like this, their blood cells look like this. If you expose them to blood that looks like this, that is foreign. The body's going to go, wait a minute, well, what is that? That doesn't belong here, because the body isn't used to that. It's used to the A antigen. So the B antigen is a foreign antigen. If that happens, that person's body, type A person's body, will make anti-B antigens. Antibodies. basically to attack this antigen. Okay, so you've got anti-B antibodies attacking this B antigen. Why? Because in my body, type A is normal, type B is some weird foreigner who shouldn't be there. The problem, if you give somebody a pint of the wrong blood, remember the agglutination we talked about? That's going to start massive clot formation in their bloodstream. They're going to end up having a stroke. They're going to end up having some type of embolism. It's going to be bad, maybe even a heart attack if it causes enough clotting in the heart and heart tissue starts to die. This is one of the reasons why we do not just willy-nilly give people blood. Now, there is one type of blood that you can give that will cause no reaction because there is nothing on the surface to react to. O negative. O negative is commonly referred to as the universal donor. Now, the reason it's called the universal donor is because there is nothing on the surface for the body to recognize as being foreign that it will react to. So there isn't that response of agglutination and making antibodies and doing all of that. Okay? Now, one of them is called the universal recipient because it has all the antigens on it. So it can't actually make any antibodies or it would be attacking its own cells. That's this one right here. I've got A, I've got B, and I've got RH. If I were to make any of those antibodies, I would be attacking my own cells. So AB positive is the universal recipient. Recipient. I can't spell, so you know what I'm saying, but it's probably spelled wrong. So I can literally give B negative to AB positive. Why? See that? It's the same. So it's not going to see it as something foreign, as something that doesn't belong there. I can give them type A. There's the surface antigen, there's the A antigen, put it in their body, and they're fine with it because they recognize A as being normal. I can give them type O positive. They have this same antigen, so it's perfectly fine. There's nothing wrong with that. In fact, I can give AB positive any of these, and it'll be just fine because it recognizes all of those antigens as being normal. Okay? So, case study. Antibodies don't develop unless they're exposed to a foreign antigen. So antibodies aren't just present automatically. Your body actually has to be exposed to them in order to make antibodies against it. I'm sure everybody understands that more recently because of COVID and how everybody, well, if you've had it, maybe you need to go and donate blood so they can get the antibodies. Your body doesn't make antibodies until exposure. But let's say that we have Frank, okay? Frank is type A blood and he gets shot. Bummer, Frank. So sad. And he needs a blood transfusion, okay? If he gets type B blood, his body is going to make antibodies to it. Eventually, there's going to be agglutination and hemolysis, and Frank is going to die from massive clot formation because B antigen doesn't match his A antigen on his own blood. Now remember something, that blood has a shelf life of about 120 days. So it's going to stay there long enough to create antibodies to it. Now, on the other hand, if your doctor is smart and knows what blood type you are, they're going to give you the right blood type. And when they do that, you live happily ever after. Yay, Frank lived. Woo! Okay. So if this is the A antigen, it would make anti-B antibodies. Notice that the shape of this crab claw is different than what we have here. Here's B. See how that would fit that? Okay. So if I have the B antigen on my cell surface, I would create the anti-A antibody. Again, look at the crab claw. It would fit the A antigen. If I am type AB, I don't make either of these. Why? Because this would attack my own cell. This would attack my own cell. And I don't want that, so I don't do that. If I am neither A or B, so I am type O, I'll actually make both of these. I'll make both the anti-A antibody and the anti-B antibody. Why? Because both of these look weird if that's what your blood normally looks like. If there's nothing on the surface here and all of a sudden you see something that has something on the surface, yeah, no. Your body's automatically going to respond and make these antibodies because it's not used to seeing that, and that's foreign. That's not supposed to be there. So what would happen if type AB, to type AB, if this antibody were put inside of it? If you guess that it would attack its own cells, it would attack these cells, you are correct. So again, you would start to see the agglutination, the clot formation, hemolysis. You would start to see all of that. So again, with agglutination, if you've got an anti-A antibody, it will bind to the A antigens on the red blood cells. Now remember what I said, the arms on this move. So if I had another one here binding, and I had another one here binding, and I had another one over here binding, eventually you would see agglutination if you had the right antibody binding to that specific antigen. Anti-A antibodies only bind to the A antigen. That's why up here they say no agglutination, because this is an anti-B antibody. This is the A antigen. It can't bind. It's not the right shape. Okay? Let's talk about the hemolytic disease of a newborn. So, Rh negative mothers give birth to an Rh positive fetus. Let's go through this. In the 1940s, 1950s, it was required that you go and get a blood test with your soon-to-be husband, and if the results were not matchy-matchy, then they didn't let you get a marriage license. And this was the reason why. So remember, if something looks foreign, your body will make antibodies to it, right? So an Rh negative woman, she doesn't have the Rh factor on her red blood cells, gets married to an Rh positive man. The baby has the chance of being Rh positive as well. Okay, just like dad, because dad donates half of his genetic material, right? So Rh negative mom is housing Rh positive baby. Now remember, in her body, that Rh factor is foreign. It should not be there. For the first pregnancy, everything goes swimmingly well because baby is basically isolated from mom in the placenta, in the womb, okay? But when the baby is born, there's mixing of baby blood with mommy blood. And when that happens, mommy now starts making antibodies against Rh factor. Now, antibodies usually last for about 10 years. So if she gets pregnant a second time and that baby is again Rh positive, mom's antibodies are going to go and attack the baby. Okay? They see the baby as something foreign, so they go after it and they kill it. Well, I shouldn't say it. They try to kill the baby's blood cells because they've got that Rh factor and that's foreign and it shouldn't be there. Back in the day, they used to call this blue baby because when the babies were born, they were born showing a lack of oxygen because their red blood cells were being destroyed by mom's antibodies. And back in the 1940s, 1950s, they didn't have a way to combat it. So rather than just allowing people to get married and then figuring out that they couldn't have kids, they did the blood test and basically said, no, you can't get married. Now, advances have been made, and there's something called RhoGAM. RhoGAM is a shot that they give an expectant mother, and it is fairly common now just to give it regardless of whether you know who's positive or who's negative. You just give it. Not only do you give it before the birth, I want to say I've heard 3 months before birth, but when mom is having the baby, they give her another shot, and what it does is it suppresses the immune system. So mom's body doesn't react, and it works for about 3 months. What are the half-life or what's the lifespan of a red blood cell? About 120 days. Again, about. So what that gives the body time to do is to get rid of those cells that may be cross-contaminated, and the mother's body doesn't have the exposure when her immune system is completely active, so she doesn't make these antibodies. Okay? So that kind of helped to nullify that issue of the cross-contamination. Now, if you don't have that, and if you do end up with an Rh positive fetus with an Rh negative mom, this will still be an issue. This will still cause problems. And that's the end of chapter 19.